We have a really special guest here on Inside the Cockpit today. It is the Bf 109 G-12. Yes, you heard right, the G-12. You don't know what that version of the aircraft is? Well, it is a twin-seat trainer aircraft that was built towards the end of the war from spare G4, G6 airframes in order to provide a better training experience for new pilots, since at that point Germany was really struggling to put out well-trained pilot. And with the 109s in particular, there are some intricacies, of course, for example, with ground taxiing, that a trainer aircraft was at that point needed and built with the G-12. However, because it is a G-12 that was built mainly out of airframes like the G-6, I'm going to be treating this as a G-6, and then every now and then I'm going to loop over to a G-12 and explain some of the intricacies there. But otherwise, I'm treating this as a G-6. Big thank you here to the Messerschmitt Stiftung in Manching, Germany, for providing this absolutely fantastic access, and of course all the patrons and channel members for making Inside the Cockpit 100% community funded. Up front, we have the VDM, variable pitch propeller, and that is being powered. As you can see right here, this is the Buchon legacy here, the Spanish 109 legacy with a Rolls-Royce Merlin engine. However, initially during the Second World War, we would have the DB605, the quintessential engine of the Bf 109 G series, installed right about here, pumping out in the A variant 1,475 horsepower. You also have the AS and the AM version of the engine, but generally speaking, this would be the DB605A would be the one installed. Sometimes you had provisions for that GM1 boost as well, which gave you roughly a 30 to 40 kilometers an hour speed boost, but that wasn't installed on all the 109s and certainly wasn't standard. Now, in order to achieve the output of 1,475 horsepower, you do need to crank her up to 2,800 RPMs at 1.42 ATA. That is not realistic it is not realistic to run the engine at that setting for overly long. So for combat, you're dropping it down on RPMs and on your ATA, and also at continuous, you're going to roughly about 2,300 RPMs with 1.15 ATA. We have the intake tube here for some of the cooling of the aircraft in the Buchon variant and the Rolls-Royce Merlin one. However, this area in the G6 would be for the oil cooler, with an oil cooler system capacity with the tank mounted further aft of 36 liters. And the liquid cooling of this V12 liquid cooled engine would be beneath the wings. And we have some footage here of a G4 as well that will show you exactly how that looks like. Further towards the wing then, let's talk about that. We have the typical sort of low wing of the Messerschmitt Bf 109, very good for mass production. It was optimized for being mass produced, and the gear itself was strengthened multiple times over the lifespan of the G series, which also created these bulges right here on the top of the wing, just in order to house the new wheel. Moving along the leading edge, we have slats. They aren't deployed right now, but they would deploy automatically when required. They are, of course, given to Messerschmitt in a license exchange with de Havilland. We have then here the navigational lighting, on the wingtip. We have the aileron with a fixed trim tab. We have flaps, as well as here the liquid cooling flaps that are also operated automatically. On your liquid cooling, you don't want to be going above 115 degrees Celsius in your Daimler-Benz powered aircraft. And on the oil cooling, you don't want to be going above 85 degrees Celsius. Now we come to this part, and we have to talk a little bit more about the configuration that we have here, because of course the G6 would be a single-seater fighter, but the G12, as we have it set up here, is a twin-engine trainer. So you have that trainer position here. The instructor would be sitting in the rear with also a internal layout enough for him to operate the machine should the student not be up to the task. And also having these extended view fairings here, which is really cool, which provides a better forward visibility, especially on taxi, because taxi in tail draggers, generally speaking, is quite difficult, but on planes like, for example, the 109 or the Spitfire and so on, it was quite difficult simply because of the position of the nose, the length of the nose. You couldn't really look over it all that well as a pilot, so oftentimes you were serpentining slightly on taxi, and for student pilots, very difficult, so having this is quite nice. However, if we go back to the G6 variant, we have the cockpit here, and below that we have a fuel tank, 400 liters, enough capacity, self-sealing by the way, enough capacity for about an hour and a half of flight time, depending on how you want to stretch that, those 400 liters. In the G12 variant, looping back towards the trainer, as you can see, the room is more limited. So instead of 400 liters, we have 240 liters, which really decreases the time, the flight time of the aircraft to an absolute minimum, which means that it became quite customary to have a 300-liter drop tank that the Bf 109 had since, basically, well, the Friedrich series already had it, and to a degree even the Emil series, or the E and the F. But that became standard to use also during training, just to extend that range again to roundabout where you were sitting with the internal capacity of the fighter, and even beyond that for a little bit of additional training time. The pilots in the G6 would also be protected up front by an armored windscreen, as well as to the back by armored plate, which was good enough to deflect machine gun rounds of a lower caliber, so 7.7, or even heavy machine gun rounds, 12.7, for example, 50 cals, depending on the strike angle, the distance, and so on and so forth. All right, coming then to the fuselage, we have the aerial mast right here, and the aerial being strung all the way to the tip of the vertical stabilizer. The aircraft in itself, in the G6 variant, the weight does go up slightly from the earlier G4 variant, and that would be then 2,600 kilograms empty, going up to 3,400 kilograms on your maximum takeoff weight. Then we have a non-retractable tail wheel just over there, and then coming to the horizontal and vertical stabilizer. The elevator has a fixed trim tab on either side, but it can also be trimmed by the pilot, where the elevator itself is being trimmed rather than a trim tab, and we have a rudder with a rudder trim tab that is fixed as well. Then we come to the internal layout of the aircraft. What we have internally mounted here are also the radio sets. Now the biggest change going from the G2 to the G4 is the radio set instead of a FUG7, so a Funkgerät 7. You have the Funkgerät 16, the FUG 16, and that would also then be retained on the G6, being coupled with the Zielflugvorsatzgerät 16 for directional finding on some missions. That's where that loop antenna comes into play, although that wasn't always mounted. And you also have the FUG 25 for your IFF. Coming then, of course, to the wing. The left wing is basically the same as the starboard wing. All the controls are mechanical, as you would expect. You have also those plane flaps again, 40 degrees deflection there, with some nice visual markers as well for the pilot to check from the cockpit at what sort of deflection he is currently flying at. Coming then to the wingtip, what do you expect? Navigational lighting, and of course also to the pitot tube. Then coming to the weaponry, on the wings we have provisions in the Gustav series for gun pods. A single MG 151-20 cannon, that is a 20 by 82 millimeter cannon, and the gun pod holds enough ammunition for 135 rounds, being fired at roughly 700 rounds a minute. However, that would be an optional armament option that would be generally used, for example, in bomber hunting sorties. The main change in the Gustav line, however, from the G4 to the G6 happens right behind me. Now, we have, of course, for a long time, since the Friedrich series, the MG 151-20, the same gun as is in those gun pods, installed it internally behind the engine, but in front of the cockpit, with, well, parts of it still being inside the cockpit between the pilot's legs, and that fires through a channel right through the prop hub. And the G6, that can be optionally changed to the Mk108, which is a 30mm cannon, and in fact Germany's favorite aerial mortar during the war. That fires a 30 by 90mm round at roughly 600 rounds a minute, and there are 65 rounds available to the pilot. Now, the Mk108 is a difficult weapon to fire. The muzzle velocity is very low, so again, aerial mortar, and its fire rate isn't great. But what makes this a standout weapon is that as a 30mm shell, it features 80 grams of high explosive filler, which is 4 times more high explosive filler than was in the 20mm cannon, and that cannon already had about double, if not triple, the amount of high explosive filler than most 20mm cannons of the time. So if an Mk108 hits, it hits. But the main change really happens not with that Mk108 gun, which is optional, but the machine guns. So initially we have the MG17s, so that's a 7.92 by 57mm round. But we have the MG131 that is being installed natively in the plane. That is 13 by 64mm, and it features 300 rounds a gun, not 500, but 300, but it now is a heavy machine gun caliber instead of a light machine caliber, so it does have a bit more kinetic force behind it. And it also fires at around about 900 rounds a minute. And that, of course, it requires the installation of those bulges that you often see on the G6 series, which is also where the jokes are coming from with the G6, because it basically has bulges everywhere. It has bulges on the nose, it has bulges here on the wing, and that's where you start seeing the limitations of the aircraft design natively that have then be ironed out as its development continues across the war, with some of these bulges disappearing again in later versions. But that rounds us off on the outside. Now, I have a treat for you, because we're going to be jumping inside. Jumping into the cockpit, there is the obvious question to ask. Is the 109 cockpit truly as cramped as they say? I already have a full video on this, so check that out for this question. For this video here, we will focus on the functional aspects of switches, levers and buttons, starting as always with the sweeping left to right inspection. The G model of the Bf 109 doesn't have a great track record for standardization, but what you are about to see is broadly representative of the G6. On the far lower left we see these two wheels. The outer one is for the flaps and the inner one is for the horizontal stabilizer trim. Moving forward, the yellow mushroom shaped button is the fuel priming pump, with the green and red handle being the left radiator cutoff. The switch for the automatic prop pitch selector is right next to this under the throttle. Looking up but staying on the left hand side here, we find the tail wheel lock. And then as we move forward, we find the obligatory throttle controls. At times this also had a press to talk switch for the radio. There's also on the side a propeller pitch switch in case manual pitch is selected. The red handle is for the fuel cock, and for cold start we have a red striped white handle. The yellow ball lever is the engine stop handle, and behind that you have a visual indicator as well if the gear is in or not. And a smaller handle to the side opens up the fuel flow from the belly tank. The gear release is found above this assembly. It's just 2 simple push rods. Moving our gaze towards the front instruments, on the lower left we find a gear position indicator. This is the electric one, not the mechanical one you saw earlier. Ein stands for in, aus for out. The red push button on this side is the cutoff for the electrical system. On this side we also find the engine starter switch, the magnetos, and this switch here that I believe is linked to the oil system, but it's a bit elusive in the sources that I have. If you have a manual that specifically answers this question on what exactly this does, please let me know in the comments. The canopy emergency release is found offset to the side. Now we move to the central instruments. This is likely the cleanest and easiest to read arrangement I have seen in a World War II fighter, and remarkably close to what we consider the norm nowadays. If you have seen other fighters in the Inside the Cockpit series, you will see what I mean as we go through this. The 109's cockpit had its share of issues. Again, watch the previous video on that. But the layout is really good for the time. Starting on the top, we have the ammo counter for the centrally installed weaponry. And below this, we have a heading and directional compass,
the artificial horizon with an integrated turn and bank indicator, and below an altimeter in kilometers and a speedometer in kilometers per hour. Moving to the right, the engine dials. On top is the ATA indicator. In function, this is basically the German equivalent to what Allied plans had with the manifold pressure indicator. There are, of course, differences in what is being measured, but in function, that's what it does. Below this, we have the RPM indicator and the prop pitch indicator. Moving further down, now with color coding, the yellow dial is the fuel gauge, and the yellow and brown one is the fuel and oil pressure. Above this, the radio direction course finder to home, back to base, and a dual engine temperature dial for liquid and oil cooling. A clock is set to the top right, while the windscreen cleaner liquid release is the yellow handle and the red pull handle is the emergency gear release. Above this, the Revy gun sight, which can be stored like a targeting computer for better forward visibility. Between the pilot's legs, the covering plate for the centrally mounted cannon, which could be a 20mm MG151-20 or the 30mm MK108 high explosive fireworks dispenser. Moving to the right, we find the Funkgerät 16, the FUG-16 radio frequency selector, and the green and white handle is the right radiator cutoff, while the switch set in front of it sets the cooling to automatic or manual or back. On the lower right, we find various additional systems. In German planes, blue signifies oxygen. This is the oxygen system with a flow and capacity dial mounted just ahead of it. The small switch is in front for the FUG-25 IFF, while the red handle is the emergency release for bombs. The two similar looking boxes are again for the FUG-25, and then we also have the radio volume control. Above all this, a couple of circuit breakers. The pedals control the yaw axis, but the stick is of course for the roll and pitch control. Let's go through the buttons here. The offset button to the side is generally the bomb release. As you can see, a safety catch covers an additional button. This would be to fire the cannon. It can only be used, however, if you move the safety catch forward, and then the safety catch becomes the trigger for the plane's guns, which is perhaps the most American thing you will ever see in a non-American plane. To the bottom of the stick then, we have the cannon charging button. And that is it, the Bf 109.
Oh, and by the way, if you want to sit inside this 109 cockpit, you actually can. Check out the description for the museum's access requirements and their schedule. I hope that you enjoyed this little quirky look at the cockpit of the 109, and as always, have a great day and see you in the sky.